The purpose of this video is to introduce the concept of polyatomic ions and to incorporate polyatomic ions into the skill of ionic naming. So far, you've learned how to name and pair ions. For instance, we've learned that the name of Mg2+ is the magnesium ion, Fe3+ is the iron 3 ion, and S2- is the sulfide ion. Each of these ions represents a monatomic ion. A monatomic ion is one atom that has developed a charge by gaining or losing electrons. In contrast, a polyatomic ion is a group of atoms that have collectively developed charge. For instance, the sulfate ion is a sulfur atom and 4 oxygen atoms that all together have picked up 2 extra electrons to have a -2 charge. Later, we'll discuss the fact that these 4 oxygen atoms are covalently bonded to the sulfur to form the sulfate ion. But for now, you just need to know that the sulfate ion is a sulfur atom with 4 oxygens that all together have a -2 charge. Let's take a look at some common polyatomic ions so that you can get a better sense of what all of this means. As you examine the polyatomic ions on this page, you'll notice that the formulas are a little more complicated than the monatomic ions you've worked with in the past. In addition, there doesn't seem to be a way to determine the charge from the periodic table. Indeed, for polyatomic ions, you need to memorize the formula with the charge and the name, because there is no way to determine charge from the periodic table. You'll be given a table of ions, and you do not need to write these down in your notes now. All of the ions on this page have a -1 charge. For instance, the nitrate ion is a nitrogen and 3 oxygen atoms, all of which have a -1 charge. Hydroxide is an oxygen and a hydrogen, which together have a -1 charge. Chlorate is a chlorine, 3 oxygens with a -1 charge, and the acetate ion, which is a little more complicated looking, is 2 carbons, 3 hydrogens, and 2 oxygens with a -1 charge. This picture illustrates a little bit of the actual bonding in the acetate ion, but what you need to know is 2 carbons, 2 oxygens, 3 hydrogens with a -1 charge. Polyatomic ions can have charges other than -1. For instance, the ions on this page, carbonate, a carbon and 3 oxygens, together all have a -2 charge. Sulfate, which you saw before, sulfur and 4 oxygens with a -2 charge. Phosphate, which is a phosphorus and 4 oxygens with a -3 charge. And then our lone cation, ammonium, that's a nitrogen and 3 hydrogens with a +1 charge. Let's see how these polyatomic ions fit in with the skill of ionic naming. Here you'll notice a table of polyatomic ions, both formulas with charges and names. Let's begin by trying to determine the formula for the ionic compound magnesium nitrate, which is made of the magnesium ion and the nitrate ion. Magnesium, of course, is a 2+ ion. Nitrate is a 1- ion. So we'll need 2 nitrate ions for every 1 magnesium ion. That formula is 1 magnesium with 2 nitrate ions. You'll notice the parentheses in the formula. This means that there are 2 nitrates and only 1 magnesium. Let's try again with aluminum sulfate. Aluminum is a 3+ ion. Sulfate is a 2- ion. We've seen in the past that when we pair these, we'll need 2 aluminum ions for every 3 sulfate ions. The way we would write this formula is Al2 and SO4, 3, to imply that there are 3 sulfate ions for every 2 aluminum ions. One common mistake is that people will write the charge in the ion. We didn't write the charge in the ionic compound for monatomic ions, and we won't do it here with polyatomics. Let's try working backwards from a formula to a name. This particular compound contains 3 Fe ions and 2 PO4 ions. If I check the chart on the top of the page, I'll notice that this is the phosphate ion, and it has a charge of -3, which tells me that each of the irons is a 2+ charge, and this compound is named iron 2 phosphate. Pause the video and use the chart at the top of the page to try to determine the formulas for each of these ionic compound names. Unpause the video when you're through and check your work. Ammonium oxide is the pairing of NH4 plus 1 with the O2- ion, so the formula is NH4,2O. Potassium carbonate is the K+1 ion paired with the carbonate ion, and we get K2CO3. Lead 4, that's Pb with a 4+ charge, so I'll need 4 of the -1 hydroxide ions to make a neutral compound with Pb4+. Calcium chlorate, Ca2+ ion, I'll need 2 of the chlorate ions, each of which has a -1 charge, to make a neutral compound. The sodium acetate compound, Na plus paired with C2H3O2-1, it's a +1 ion with a -1 ion, and so we just link them together. Now what about copper 2 nitride? Did I trick you? This is the copper 2 ion with the nitride ion. That's a monatomic anion. So when we pair these, we get Cu3N2. I chose this example to highlight the similarity between the name nitride and nitrate. The ions that end with IDE are our previously studied monatomic anions. I got the charge -3 by using the periodic table. The endings with 8, those I have to memorize. I got the formula NO3- because I had memorized that the nitrate ion is NO3-1. Flashcards are not a bad option for preparing to use polyatomic and monatomic ions together with ionic naming.